Alright, for example number 4, they're asking for the 6 trig ratios of theta if we are in negative 1520. So here's the point negative 1520, and so I'm going to draw a line out that direction, and so here's negative 15 and here's 20, and then to find this 6 trig ratios, really we need to do the Pythagorean theorem. Now, knowing that we need to find the hypotenuse, negative 15 squared plus 20 squared is 625, and so we get an answer of 25. Now, because it is the hypotenuse, it is always going to be positive. Here is the opposite, and here's the adjacent. So the sine of theta is equal to the opposite, which is 20, over the hypotenuse, which is 25, which turns out to be 4/5. The cosine of theta turns out to be negative 15 over 25, which turns out to be negative 3/5. And the tangent of theta is equal to 20 over negative 15, which equals negative 4/3. The cosecant is the reciprocal of the sine. The secant is reciprocal of the cosine, and the cotangent is reciprocal of the tangent. Let's do one more of these problems. Alright, let's try this again, and let's use the point negative 2, negative 5. So negative 2, negative 5 is going to be in the third quadrant. I know my picture is not drawn to scale, but when I do negative 2 squared plus negative 5 squared, remember the triangle always has a line along the x-axis, gets me 29, so the square root of 29 is equal to c. Here's my opposite, here's my adjacent, here's my hypotenuse, and so for the sine of theta, we get negative 5 over the square root of 29. For the cosine of theta, we get negative 2 over the square root of 29, and the tangent of theta is negative 5 over negative 2, which is 5/2. Cosecant theta, square root of 29 over negative 5. Secant of theta is equal to square root of 29 over negative 2. And the cotangent of theta is equal to 2/5. Alright, for problem number 5, and we'll do 2 examples of this one. It says that we're in quadrant 4, and they tell us that the secant of theta is equal to square root of 29 over 5. Now the easy thing to do is to make sure that the cosine is the reciprocal, so that's 5 over the square root of 29. So here's my picture. Here's 5, and here's the square root of 29, because I know that this has to be the adjacent over the hypotenuse. So if it's not exactly this triangle, it's one that's similar to it. And so I need to once again do my Pythagorean theorem. 5 squared plus b squared equals the square root of 29 squared. So we got 25 plus b squared equals 29. Subtract the 25, and b squared is equal to 4, which means b is equal to 2 plus or minus. The reason why I say plus or minus is because we have to decide, and in this case, because the triangle is down, that's going to be -2. So, now based on this triangle, I know that the sine is -2 over the square root of 29, and I know the tangent is the opposite, which is -2 over the adjacent, which is 5. So that is one example where they give you they have to give you one of the trig ratios and which quadrant it's in. So let's try one more. Alright, so this time they give us quadrant 3 and they tell me that the sine is -2/3. So I need to find the other 5 and the easiest one is, since I already have the sine, I have the cosecant. And so I'm going to draw my picture, quadrant 3, part of my triangle is on the x-axis, then I go down, and then I go back to the origin. And since we have the sine is -2/3, that's the opposite over the hypotenuse. So a squared plus -2 squared is equal to 3 squared. A squared plus 4 equals 9. Make sure that this is a positive 4, because when I subtract it, I get a equals 5, which means this is the square root of 5. Now that I have my triangle all set up, the cosine is the square root of 5 over 3, and the tangent, which is the opposite over the adjacent, is -2 square roots of 5. There's the hypotenuse, there's the opposite, there's the adjacent. The secant is 3 over the square root of 5. Actually, I made a mistake because this square root of 5 should be negative. I'm sure you were all saying that at this time. So this cosine should really be negative square root of 5 over 3. And then here we got 2 negatives, and the 2 negatives become a positive. So this should have been negative, and the square root of 5 over 2 here is positive. One way that you can always check to make sure that you are positive is something that I like to call all students take calculus. You remember all students take calculus. This means that all are positive over here, and we're just talking about between sine, cosine, and tangent. So in quadrant number 2, it's just sine. In quadrant number 3, it's just tangent. And in quadrant number 4, it's just cosine. So whenever you do this, just make sure that you check to make sure your signs are correct for the sine, cosine, and tangent. In the first one, all. Second one, sine. Third one, tangent. Fourth one, cosine. Take a picture of this and send it to, and take a picture of your notes and send it to your Google Drive, and that'll count as your opener for today.